So next problem, I had continued previous class and two problems on displacement, distance, and average speed and average velocity. Now here, Abdul, while driving at school, driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip, along the same route, there is a less traffic and the average speed will be 30 km per second. What is the average speed of Abdullah's trip? Here what happens? So, in a driving school, so Abdullah went driving. So, average speed he computes one trip 20 km per hour time will be taken. On his return journey, what happens? On this return, the same route will come, but there is less traffic and the average speed will be 30 kilometers. So less traffic will be there, speed will be increases and distance also be increases, 30 kilometers per hour. Now I had to calculate the average speed of the Abdullah trip. I had to calculate. Now question will be Abdul while driving school, computes the average speed for his trip. The average speed for his trip to be 20 km per hour. 20 km per hour. On his same route, there is less traffic. And the average speed is 30 km per hour. 30 km per hour. What is the average speed for Abdullah train? What is the average speed for Abdullah train? That we have to calculate. Now in this case, we have to consider distance travelled to reach the school is equal to distance travelled to reach home. So both will be equal in this case. So same route he will be considered. That's why what the distance travelled. So to say from school to home to be considered. So distance travelled to reach the school is equal to the distance travelled to reach home. Both will be equal. Equidistance will be there. So distance travelled to reach the school. Distance travelled to reach the school. To reach the school is equal to distance the distance travelled to reach the home. So the distance will be taken as d. So both will be equal. That means total distance covered means to consider afterwards what consider here distance to be considered as a d meter. So time taken to reach school will be t1. Time taken to reach school is equal to be considered as g1. Now, average speed while to going to school is equal to distance by time. So average speed, AS means average speed is equal to distance, D by time taken will be T1 to be considered. So D by T1 to consider as D1, that value is equal to, so what is that value? This average speed is equal to 20, 20 is equal to D by T1, 20 km per hour will be given now. So that's why I write as 20 km per hour. That will write as D by T1 is equal to 20 km per hour. It's given in the question. Now finally you can make the calculation. Here keep like that. Now average speed Y going home is equal to, so D by T2. So that D by T2 is equal to how much? 30 km per hour. So 30 km per hour is equal to D by T2. So D by T2 is equal to 30 km per hour to be considered. Now so in this I will make T2 a subject. T2 is equal to D by 30 hours. Similarly here also to consider T1 is equal to D by 20 hours. Now what you want? Average speed of his journey to be made. Average speed of the journey. Average, this means average speed of the journey. After average speed is equal to total distance by total time. So total distance will be taken as D plus D by total time T1 plus T2. That is equal to total distance is D plus D means 2D. By total time means D by 20 plus D by 30. Now take LCM for 20 and 30. So 20 and 30 LCM to be considered 5. 5 4s are 5 6s are 2. 2 2s are 2 3s are 2 3s are 6. 6 2s are 12 16. So that is equal to 2D by 60. Now 23s are 3D plus 32s are 2D. Now what do you get? 2D by 5D by 60. Now what do you write? 2D into 60 by 5D. So two fractions will be there. Second fraction denominator go to the numerator and the first fraction. Now D gets cancelled. 5 1s are 5 12s are 12 2s are 24 km per hour. So his average speed of the journey will be 24 km per hour for going and coming. Total average speed to be considered 24 km per hour to be taken. So it's an important model. So here to calculate the time first. For that average speeds will be given for going and return journeys. Now by taking that we can calculate first T1 T2 values. Now distance will be same. That's why D plus D we get 2D. Right? We can do like that. So this model is very important one. Now next another one to be considered. Next question to be considered. In this, a motorboat starting from rest on a lake accelerate in straight line at constant rate of 0.3 meter per second square for 8 seconds. How far does the boat travel during this time? So now we can calculate the distance, how much distance it will be covered for the given time, we can be calculated. Here what happens, a motor boat in water, it will be travels, a motor boat, starting from rest, on a lake, accelerates in a straight line at a constant rate of 0.3 meter per second square, that is an acceleration, 0.3 meter per second square for 8 seconds. How far does the boat travel during this time? Now here, what is the given thing? Boat starting from rest means initial velocity will be 0 and acceleration will be given, distance to be calculated. So what the application we have to do? S is equal to ut plus half at square I had to apply. Okay, by applying that application we can calculate the distance covered. How much distance it will be covered, we can calculate. Here a boat starts from rest. So initial velocity u is equal to 0, acceleration a is equal to 0.3 meters per second square, and time taken t is equal to 8 seconds. Then what is the distance traveled by it? S is equal to how much? So S is equal to ut plus half at square, that is equal to 0 into 8 plus half into 0.3 into 8 into 8. Now 0 into anything will be 0. 0 plus 2 ones are 2 fours are 8. 8 fours are 32. So 0.3 into 8 fours are 32. So now we have to calculate. So your acceleration will be acceleration is 3 meters per second. Acceleration is 3 meters per second, not 0.3. 3 meters per second will be given. So 3 meters per second means 32 into 3, that is equal to 96 meters. Distance traveled is equal to 96 meters. Acceleration will be 3 meters. So I wrote 0.3 is not 0.3. So 0.3 means just we get 9.6 value get it. But 3 meters will be given in the question, so I have to change that to 3. So 3 meters acceleration, 3 meter per second square acceleration to be taken. Now I have to substitute. U value will be 0, time will be 8 seconds, plus half into 8 square. A is 3, 8 into 8. So 2 ones are 2 fours are, 8 threes are 32. 32 into 3, that is 96 meters distance traveled by the boat. Okay. Now another one. Here, a driver of car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 3 km per hour in another car applies his brakes slowly and stops 10 seconds. On the same graph paper, plot the speed versus time graph for the two cars. Which of two cars travelled further after the brakes were applied? So here we had to draw the graph also. We can indicate graph to be shown. Here kilometers per hour to change into meters per second. Meters per second we have to change that value. Then we can easily plot the graph. So here first to see the question. First observe the question. Question will be: a driver of car traveling traveling 52 km per hour, 52 km per hour, applies the brakes and accelerates uniformly in the opposite direction. The car stops 5 seconds. The car stops in 5 seconds. The car stops in 5 seconds. The another driver going at 3 km per hour, only 3 km per hour in another car and applies his brake and applies his brakes slow and stops in 10 seconds. Now I have to plot the graph for this. So on the same graph, plot the speed varies time graph, speed versus time graph for the cars which travel further after the brakes were applied. So there is So here, so in this question, two cars of one of the speed 52 km per hour. After applying the brakes, 5 seconds it will come to stop. Another car travels on 3 km per hour. So after application of the brakes, 10 seconds it comes to stop. To plot the graph for these two cars' speeds, then speed and time graph. Then after, which one stops earlier? That is after application of the brake. So first of all, we can change these values into meter per second. Further, we have to plot the graphs because kilometer per hour. We can draw the graph. Okay, next class it will be continued.